In this video, we'll be learning about introduction to stack, the applications of stack, how we are going to implement the stack using array or linked list, and the operations of stack. So now we'll see what is a stack. Stack is one of the linear data structure. Why? Because we are going to store the elements in the stack continuously in an ordered way. We cannot store the elements in an unordered way. We cannot insert or delete any element in an unordered way. Either we can insert in an ordered way or remove an element in an ordered way only. So only we call stack as a linear data structure. So what is the rule of a stack? Insertion and deletion can be performed only at one end. Always in stack, one end will be closed and one end will be open. So only insertion can be made only at one end, as well as deletion can be performed only at the same end only. So this is the representation of a stack. So we can consider an example. Consider a CD player storage. So how will you store your CD? First you will be inserting one CD, the first CD. Then second you will be inserting the second CD and followed by the third CD. So what you have inserted at the first will be stored at the last place, right? So if you want to remove a particular CD, what you have inserted recently, the third CD, last you have inserted, right? That only will be removed first. Why? Because only one end is open. So last what you have inserted, that only will be removed first. So only we call stack as last in first out or first in last out. Stack can only be used for only limited data. Suppose if you want to access or store any limited data, you can implement using stack. It is not applicable for large data. Okay, and one more information about stack is only you can use same data type in stack. It is of homogeneous data type. Only either you can store integers, or you can store characters, or you can store floating values, only of same data type. Because see, here you can store 1, 2 and 3, but here if see I'm writing here 1, here I'm writing here a and 2.2. so one is integer, one is character, one is floating value, right? So you can't store like this is not possible. So stack is of homogeneous data type. Only you can store same data type. Okay, so next we'll see the operations of stack. What are the stack operations? We have basic traditional operations such as push, pop, peek or top, is empty, is full. These 5 are the main operations, or we can call it as the basic operations of stack. So what is push? Push means you are going to insert a particular element. Pop means you are going to remove particular element from the stack. And what is peek? Peek, or we can also call it as top. It tells the topmost element in the stack. Is empty checks whether the stack is empty or not. Is full checks whether the stack is full or not. So we'll see with an example. So here you have a stack. Okay, this is a stack. You have elements. The stack size is of 5. So how many elements you have? 0, 1, 2, 3 and 4. So it always starts from the index value 0 if you are using an array. Consider an array. So 0, 1, 2, 3 and 4. So initially my top will be, I am setting the top value as -1. Some hypothetically I am setting it as -1. Okay. Now what you have to do? First you have to check. Say for example, if I am calling the first operation pop. Pop means what? You are going to remove the element. So initially in my stack I am not having any data. If I am not having any data, if I call pop, what will happen? It will give an underflow condition, because you cannot delete any element, because your stack is empty. You cannot delete any element as you have no data in the stack. And if you are calling pop, what will happen? It will lead to an underflow condition. Likewise, if the stack is full, okay, and if you want to insert particular element in the stack, it will lead to overflow condition. So always whenever you are performing the stack operations, you have to check whether the stack is empty or full. Okay, so if it is empty, you can insert. If it is full, you cannot insert. Okay, so now I'm calling the push operation. Push means always, remember one thing, you have to pass the value what you're going to insert. So in push you have to always pass the value whenever you're performing the operation. So push of 2, I'm passing the value 2 as an input, or you can just declare a variable x and you can get the value from the user. Okay, so anything is fine. So push of 2, here I'm directly inserting the value push of 2, I'm calling push of 2. So what will happen, you're going to insert, suppose in case the stack is empty, you can insert. So now when you're inserting, what you have to do, you have to increment your top. Already my top will be -1. If I'm incrementing top plus plus, what will happen, top will be pointing to 0. Now that once you have inserted your element, the top is pointing to 0. Okay, now again I'm pushing another value 3. Now I'm inserting the next value and I'm incrementing the top will be at 1, and so on. Whenever you are performing the push operation, your top you have to increment. So the index value, it will be pointing, the top will be pointing to the corresponding value. And next, if you want to pop, now currently what is there in my top is pointing to 1. So if you are popping, pop operation need not pass any parameter, as you are going to just pop the topmost element, obviously, because you have only one end. So what is pop operation, 3 will be removed. So 3 will be removed, and what you have to do, you have to decrement your top. So top will be again coming to 0. Top minus means top is in one position. If you decrement, top will be pointing to 0. So this is the basic operation of how the stack is performed using push, pop. Now for example, if you use peek operation, okay, if I am calling peek operation, what is the topmost element here? Now for top is pointing to 1 means what is at the topmost position? I am having 3 only, so 3 will be printed. So this is all about peek. Peek will tell you what is currently the top pointing to. Okay, what is the stack data currently in the top position? It tells the data of the top position in the stack. Now I am pushing all the operations. For example, this is a stack. So you have 0, 1, 2, 3 and 4. All the data I have inserted. Okay. Now I am going to push 8. So what will happen? Already the stack is full. My stack size is 5. So what is my stack size? 5. But I have inserted the data. So size is 5 means size minus 1. So what is size minus 1? 4. So what will happen? This is overflow condition. You cannot insert any data as your stack is full. So now what will happen is full function will become true. Okay, so this is all about the stack operations. We learnt what is a stack, then we learnt about the operations of stack, push, pop, then peek, then we learnt about is full and is empty operations. Now we'll be learning about applications of stack, where and all stack is used. So stack is used for reversing a string. So now example, you have A, B, C, D. You're going to use this stack and reverse the string as D, C, B, A. So you will first push A, then we will push B, then you will push C, then you will push D. Then when you print, what will happen? What is inserted at the last will be removed first, right? So D you will be printing, then you will be printing C, then you will be printing B, then you will be printing A. So this is one of the application of stack. Then undo mechanism. In text editors, when you perform undo, Control plus Z. So what will happen? Whatever you have done recently, that only will be removed, right? Changes will be done when you perform the undo mechanism, which is implemented using stack. Next is recursion or function call, where what is recursion? You will be calling the function will call again itself. So what you can do is the function can be stored in the stack. So at times when you use the recursion function, it will take from the stack and you can call the function repeatedly. Next, you can use balancing of parentheses. So the compiler uses stack for balancing the parentheses in your program, where suppose in case if you have missed out any parenthesis, so the compiler will check and it will intimate the error using stack only. Okay, and next we can perform infix to postfix or prefix conversions, evaluation of infix to postfix conversions, everything can be done using stack operations. Then other applications are you can use for topological sorting, then DFS, then you have Tower of Hanoi, tree traversals, in order to pre-order to post-order. All these conversions can be done using stack. Okay, so this is all about the introduction of stack, its operations and applications. Thank you.